Yeah, I welcome you all for this today's session for the course Designed and Analysis of Algorithm. In today's session, we will see fundamentals of algorithm and problem solving. Okay, so before designing an algorithm, what are the sequence of steps we have to follow? That we should discuss today. So these are the steps we should follow while designing an algorithm. First step is understand the problem and then decide on computational means exact versus approximate solving algorithm design technique. Then designing an algorithm, third step, and then prove its correctness. After that, analyze the algorithm, then finally code the algorithm. So these are the steps while designing an algorithm. First, we take step one. What is mean by understanding the problem? So understanding the problem in the sense we have to read the problem description carefully and ask questions if you have any doubts about the problem. And also you have to do some few small examples, hands-on examples, or any brainstorming session or any special cases and ask questions again, seek feedback if needed. So this is the way we have to understand the problem, and an input to an algorithm specify an instance of a problem the algorithm solves. Also, it is very important to specify exactly the set of instances for an algorithm needs to handle. If you fail to do this things, your algorithm may work correctly for majority of the input but crash for some boundary values. We have to understand the problem definition first, and we have to specify the instances. What are the instances needed for an algorithm? And it is also very important to specify exactly the set of instances. So if you do these things, you can understand the algorithm very easily. Then second step is ascertaining the capabilities of the computational device. So while designing an algorithm, you must ascertain the capabilities of the computational device. So for example, uh, for your algorithm, how much RAM is required? So algorithm is known as a sequence of steps, right? So in order to solve your sequence of steps, how much RAM capacity you needed, that you should analyze, and then whether you have any parallel computation needed for an algorithm, which is known as a parallel algorithm, and also how much speed and memory needed for an algorithm. So these are the things you need to analyze in second step. Then choosing between the exact and approximate problem solving. So this is the next thing you have to work on it while designing an algorithm. So we know an algorithm is called as an exact algorithm. In latter case, algorithm is called an approximation algorithm. Okay. So first, there are important problems that simply cannot solve exactly for most of their instances. Examples include extracting square roots. Second, available algorithm for solving a problem exactly can be unacceptable, slow, unacceptably slow because of the problem intrinsic complexity. Okay, so choosing between exact and approximate problem solving is needed while designing an algorithm. Then you have to choose algorithm design technique. What algorithm design technique you will follow, that you must analyze. First, understand what is algorithm design technique. An algorithm design technique is a general approach to solve a problem algorithmically that is applicable to variety of problem from different areas of computing. Okay, so you must understand what is algorithm design technique. Then you have to choose one design technique for your problem solving. Then you can create an algorithm. So this is the thing we discussed. First, they provide guidance for designing an algorithm for a new problem. Second, algorithms are the cornerstone of the computer science, because every problem in computer science we have to solve with an algorithm. While designing algorithm, you should understand the problem given to you, and you have to ascertain the capabilities of the computation units, and also you have to understand the difference between exact and approximate algorithmic technique, and you have to design an algorithm technique. Okay, then next step is designing an algorithm and a data structure. So designing algorithm for a particular problem is a challenging task always. So we have to follow some design technique. Sometimes several techniques needs to be combined with your design technique. So you have to follow some data structures. You have to use some design techniques. So, or you must combine the design technique as well as your data structure techniques. So these are the things you have to analyze. So when you are mixing an algorithm with a data structure technique, it becomes a program. Obviously, it becomes a program. So you know what is object-oriented programming, what is data structures. Already you have some idea about data structure, and because already you studied in semester 1 data structures. And object-oriented programming, you know what is object-oriented programming. While mixing this algorithm plus data structure, then it becomes a good program. So you have to analyze both design as well as the algorithm. So it is very important for both design and analysis of algorithm while writing a program. Next, method of specifying an algorithm. So there are two options. So one is a natural language. You can write algorithm with the help of natural language, because writing clear description of algorithm is very difficult. So obviously we have to use natural language. Then pseudocode, we can use it for describing an algorithm. So it is our next version of an algorithm. So also a pseudocode is a next version of algorithm, but you are not following any syntax. This is a, in simple word we can say, code without syntax is nothing but pseudocode. So pseudocode is usually more precise than the natural language, because in natural language you will describe each step lengthier, but in pseudocode you must follow certain rules to write a step. So it is more precise. It should not follow any syntax or semantics. That is what the pseudocode. And flowchart, obviously, you know, it is a diagrammatic representation of an algorithm, or we can say pictorial representation of an algorithm. Then you have to prove the algorithm correctness before designing an algorithm. So you have to give some inputs and check the result, and you have to give some complex input. Then you have to get the result. You have to match the result with the original things. Then you can analyze the algorithm correctness. Then common technique to solve prove the algorithm correctness is a mathematical techniques. All there are plenty of mathematical techniques are there. Then analyzing an algorithm, you have to analyze the algorithm in two ways. We can analyze the algorithm either with the help of time and space. How much time your algorithm is going to take to solve a problem. At the same time, how much space it required to solve the problem. How much space and how much time needed for an algorithm to solve a problem. You have to analyze these two things. We'll see in next session and in elaborate manner or time efficiency and space efficiency and all. Then you know the characteristics of an algorithm. You must write an algorithm in simple way. It should be understandable to anyone.
So that is the main thing. Then your algorithm should have a generality in the sense, it can be understood by everyone. So that is what the, again, I can say, generality. Yeah, in generality, we can face two issues. One is, there are situations where designing more general algorithm is unnecessary or difficult or even impossible. So it is very difficult to write a generic algorithm. For example, it is unnecessary to sort a list of n numbers to find its median. Okay, so likewise we have different issues. So we have to check the issues while writing generic algorithm. Likewise, we have a second issue, like a set of inputs. Your main concern should be designing an algorithm that can handle a set of inputs that is natural for every problem. If you are not satisfied with the algorithm efficiency, simplicity, and generality, you must return to drawing the board and redesign the algorithm. Okay, so this is not the exact analysis. So you have to check the efficiency, simplicity, and generality of an algorithm. If it is not fit to your problem, you can redesign the algorithm. Final step is you have to code the algorithm. Once you did all those steps, you can code the algorithm using any language. So you know how to code the algorithm. And these are the some important problem types. We have a different problem types. These are the common problem types: sorting, searching, string processing, graph problems, and combinatorial problems, and geometric problems, and the numerical problems. So these are the some common problem types, so we can solve in day-to-day life. Sorting problem, string sorting and numeric sorting. So rearranging the item either in a decreasing order or ascending order. So this is the sorting type of problem. So we can sort with the help of key or any other value. Okay, so using key, we can sort the items. So this is what the sorting problem. And sorting problem, we have two properties. One is called stable property. If it preserves the relative order of any two equal elements in its input, it's known as a stable property. Then second one is the amount of extra memory request for an algorithm. Okay, these two things are two properties of sorting. And searching, again, searching is with the help of key only we can search the element. So searching technique. Then string processing. So we know string processing, where plenty of string processing things, string matching, string comparison. So these are the string processing. Then graph problem, we have a number of graph problem like transportation, communication, then economic network, project scheduling. So these things we can do it with the help of graphs. So this problem types we can solve with the help of algorithm, and traveling salesman and graph coloring problem. So these are some problems we can solve with the help of algorithmic technique, and we'll see in the upcoming sessions in detail. Okay. In combinatorial problem, it's a mathematical thing. Okay, we can solve some permutation and computation combination things with the help of an algorithm. Then geometric problem, already lines, points, polygons, 2D drawing, 3D drawing. So these things we can solve with the help of algorithm. So convex hull, closest pair problem, example for this geometric problem. So these things we'll see in the upcoming sessions in second unit, third unit, and all. Okay, numeric problem, so equation solving or integration, okay, and evaluating any function and so on. And fundamentals of analysis of algorithm efficiency. Already I said there are two things. We have to check
how much time required for an algorithm, also how much space required for an algorithm. These two things are calculate the algorithmic efficiency. So also performance of an algorithm, we have to analyze the time and space complexity to in order to calculate the performance of an algorithm. So you know what is space complexity? Yes, exactly. It is defined as amount of memory required for algorithm to run. Okay, space complexity. So for each algorithm, the space complexity differs. It's based on the input and the variables we are using. Okay, these things determines the space complexity. We'll see how to calculate space complexity in upcoming session. Just understand what is space complexity. It's a space required for an algorithm. Same way, likewise, time complexity of an algorithm is the amount of time required to run a program. Okay, run a problem. So this is time complexity. Execution time of an algorithm, we can say, or system load, number of other program running parallelly, instruction sets. So how many times the loop is running, frequency count. So these things are very important in time complexity. So again, time complexity, how we are measuring the time complexity, number of basic operation executed and number of times the operation is executed. So these two things are very important while calculating the time complexity. That is why the time complexity is equal to number of basic operation as well as basic operation to execute as well as number of times the basic operation is executed. Okay, so if you have one basic operation without loop, the time complexity is very simple, very different, very small. If you have a loop for a basic operation like sum of n numbers or sorting of an array, so we have a loop. In those cases, the time complexity is somewhat higher than the basic simple basic operation. So we'll see in the upcoming session how to calculate time complexity. So this is the order of growth. As you all know, order of growth is from 1 to up to n power n. Okay, so that growth order of growth and all we'll see in the next class. So that's all about the today's session. In next class, in next session we'll see about asymptotic notation. So this is the thing we can denote time and space complexity for an algorithm in a simple manner, that is known as asymptotic notation. So there are three type of asymptotic notation. We'll see in the upcoming session what are the three notations are there to represent a time complexity for an algorithm. So it is a simple way to represent time complexity of an algorithm. Okay, so different algorithms have different time complexity. Time complexity may be in a lengthiest function, but we have to specify that lengthiest function into minimized or simple way to denote a time complexity. We can use asymptotic notation. So we'll see in detail in the upcoming session. So till order of growth, I'll wind up this session. Thank you. Thank you all. Thank you all for this session. Thank you.